traditional view of carbon cycle only considers the vertical gas exchanges between the land and oceanic reservoirs, and it neglects the inland water rows, which is going to overestimate the land sinking capacity. So in order to have the more reliable projection of carbon cycle, we need to integrate terrestrial, freshwater, and marine ecosystem. First part in this continuum is the connection between the land to the river system, and that's what I'm representing right now in my model. I'm working on the terrestrial carbon cycle and also its lateral transfer to the river system. My research consists of 3 phases. Phase number 1 was developing an extension to joint UK Land Environment Simulator, or JULES in short, in order to represent the dissolved organic carbon process inside the soil and its lateral transfer to the river system. The second phase was to evaluate the developed model by means of the dissolved organic carbon measurements which we had from the soil. And the third one is right now running the different experiences with the model to understand the historical and future trend of this lateral transfer and also the human impact on it. We test our developed model on 5 sites in the Central Europe, in US, and in South Asia, in Taiwan. We figured out that our model is capable of representing the correct trend of the dissolved organic carbon concentration in the soil in these sites. Right now, we are going to work on the global scale and to represent what was the perturbation of this flux based on the human activities and which are the hot spots of this increase or decrease and what were the reasons. The aim of my project is to improve the abilities of the land surface models, LSM in short, such as JULES. LSMs are a component of Earth system models. These models are counting for the carbon, land, and carbon, water, and the energy fluxes on the land. There are still missing some key processes, such as the lateral transfer of carbon to the river system. So as you can see on this PowerPoint, you can see the different fractions of the carbon being transferred, whether it's by means of erosion, which is a POC, or if it's the inorganic carbon, which is DIC, or if it's going to be the organic carbon, which is the DOC. So these are different fractions of the carbon being transferred from the soil to the river system. By having 37% of that, including the DOC, we understood that it's a significant flux that we have to represent that. This flux has been missed in most of the land surface models. So we developed the first model which is capable of representing this flux at the global scale. DOC, dissolved organic carbon, is having an impact on the formation of the soil and the microorganism activities in the soil. Also, it has its own impact in the aquatic continuum. In my model, is going to be the river. So understanding the fluctuation and the increase or decrease of this flux is going to have an important role in future decision making and mitigation.